to give a bit of a background first about what is DevOps, what is AppSec, and then how they come together. So I expect some of you already know those things, but I learned from my experience that building a strong basis in the of information, of understanding, usually helps understanding deeper subjects. So that's where we were going to go. So we're going to start with the era of pen testing. Before CI/CD, before DevOps, before automation, we had, or in the before times, as people usually call it, we had the waterfall. Waterfall basically means that everything flows in one direction. This is a slow process where when we developed solutions, and I think that most of you can remember, we don't need to think that much back. Think about, let's say, Adobe Photoshop. Before they had a cloud version, each year or 2 years or 3 years, you had a new version of Photoshop coming out and everyone was very excited. Think about Microsoft, Windows, right? So we had Windows 25, 28, second edition. It took a lot of time for each new product to come out to the market. And this is because most of those things worked with a waterfall, not continuous release cycle, like we're used to today. So waterfall basically means, releasing between every 8 to 12 months release cycles. When we're talking about security, then, you have time to do penetration testing, you have time to do full security. You can take a team that has a lot of time in their hands to go through each and every part of the application of the solution that you want to take out. And even then, things can go wrong, right? And if they do, we get, again, a very long cycle between the finding of the vulnerability and the patch coming to you, right? Think about big and critical severity items. In waterfall, those can take 4 months, 5 months. Think about your D-Link, your routers in your homes. When did you update them last? Right? No one updates them. If they have a critical vulnerability in them, it takes a lot of time until they get any kind of updates. And this is how it was for everything. But there was an upside. Even with all of that, there was an upside, and that is that security was in sync with development speeds, which means that at least security could say, all right, we did our best evaluating the solution, the product that you're going to put out there, and from the best of our understanding, it should be fine. But then, the world progresses, and we thought, we need to release quicker. We don't want people to wait half a year for a new feature. We want to push more software. We want to get features quicker. We want to update things, right? When we have bugs, even not security related, we just want to develop quicker. And this is why today, most of the software that you use is using either a continuous release logic, like if you're using Windows, then every 2 days you have a new patch to update, you have a new Windows updates coming, your phone, rings and says, I have an Android update that I need to do, because everything is always flowing forward. Now, that sounds good, right? So this is where we brought DevOps. Now, what is DevOps? So DevOps is the idea of bringing infrastructure and operations and IT and all of the not really R&D helpers to the R&D, and allow those two teams, the development and operations, to work together in a continuous cycle. For those that were not developers 10 or 15 years ago, a lot of time was wasted for things like, hey, can you allow this port to be opened on this VM that I need to set up? Can you increase this memory? And those things took time. And you can't develop quick when you need to wait 2 days for someone from IT to get an email and respond back to you. Now, this is just part of it. A lot of emphasis on newer DevOps approaches is also to do a continuous learning. So monitoring, planning, releasing, testing, deployment, monitoring, planning, coding, building, and all of that. You can see the figure 8 flow. And it's really like that. We just want to do a continuous, endless flow. We get improved development frequency, faster time to market, lower failure rate, shortened lead between fixes, and faster mean time to recovery, right? Because we can fix things quicker. And of course, the other things like improved collaboration between operations and development. It increases the efficiency, and everything that increases in efficiency reduce costs, right? There is a very focused look at automation, which again saves money, saves time. All of that sounds amazing. Customers happy, we're happy, more money for the customer, for the company. Everyone is great. Sounds amazing, right? What can be the problem? If before DevOps, we looked at something between 8 to 12 months or between each release, now we're talking about each release or each build every 2 or 3 minutes. Some companies go quicker, some companies go slower, but usually we're talking at least a few builds a day. And when that happens, even the best penetration testing team out there can't follow up on that. Think about doing a full penetration flow. That's usually something like 2 weeks of work. Going through the application, finding all of the vulnerabilities, creating a report, making sure that the developers get this information and act on it, and then verifying all of that again, right? This process takes a lot of time when it goes manually. And if we're talking about a build every 2 to 3 minutes, and we have 24 hours because, part of the company is in Europe, part of the other part of the company is in the US, and it all connects to one big workflow, it means that we need to pen test 720 builds a day. Obviously, that's not humanly possible, and we need more people, right? So maybe that's how we solve it, right? Can't we just hire more people? No. The reason we can't just hire more people is that there is just a very large imbalance between developers and security professionals out there. For each, for every 500 developers, there's one application security expert. And that means that there is just no way that we can even get to a situation where those numbers adds up, right? If my team has 99.8 developers, there's only 0.2 AppSec professionals in it. And that's for a team of 100 people, right? So in 100 people's team, there isn't even one AppSec engineer. So there is a growing demand. More companies need more AppSec, more people, more penetration testing. Our application gets bigger, more complex. There's more things to test, APIs, GraphQL, REST, all of those things create a larger and larger attack surface. And we're just getting deeper and deeper into the mud. What do we do? Security had to learn to sprint. Basically, going from shoveling everything that DevOps does and running after them, we're moving into sharing the concept of security and security processes with the DevOps cycle. Now, this might seem a bit weird. Aren't we just throwing the responsibility on someone else, but not exactly. So what we're aiming to do here is to say, all right, we have DevOps. We have those practices, those people that are very strong with automation. They are already integrated a lot of tools, a lot of smart processes through the development. Can't we just take this line of thought, this CI/CD pipeline, this new SDLC concept, and share security with it, right? Inject some security into it. So we're talking about security here, security, the HR security, but what's that security, right? Security is a very large word. Usually when we talk about security in the pipeline or security as part of the application development, we're talking about something called AppSec or application security. Right now, and this is based on Verizon's the year 2023, 2023, research, more than 80% of breaches happens due to web application issues, right? Now, when we're talking about applications, or even more specifically, web applications, right? This is the main place where companies and organizations get hacked from, right? If you look at the amount, you would thought that most of those will be some very complicated 0 days, or some tricking people, going through all kind of emails and malwares, but no, the basics. Basically, you're right. Now, the main problem with web applications is the basic tests. And again, this is what we see from Verizon's the Bureau's research. Basic web attacks are still the most major attack vector when looking at compromising applications. And everything we do today is application-oriented. Your phone, those are applications. Your phone talks to some REST API server that runs somewhere, and that's where all your data is. Your smart cameras, centralized servers, your smart car, your cryptocurrency, everything that we work with, we do is application. All right, so we define that security. We know that we call it AppSec. We define the DevOps. Now, how do we actually integrate them? Because DevOps and AppSec works beautifully together, right? We are securing the SDLC. We have quicker cycles, which means quicker fixes. We have automation, and we can find issues early on. Looks amazing. This is DevSecOps. And the idea behind introducing security into that DevOps cycle or DevOps concept. If you see, it looks very similar, right? We didn't change anything in the DevOps flow. We're just kind of blanketing all of that with security in mind, because that's the idea. We want to keep it simple. So DevSecOps is just an extension of the DevOps philosophy, and it means integrating security practices into the already developed DevOps cycle, right? So when we code, when we plan, when we build, when we test, when we do the releases, when we do the deployments, when we do the monitoring, each part of that should also have a counterpart, which is security oriented, right? So when we're doing planning, we do security planning. We want to create a new feature. We want to implement, let's say, we're creating a new web application. We're going to have a chat interface. All right. What risks could this chat interface bring? Is it LLM based? Do we have LLM issues? Is it reflecting the text that we're putting in? Can it be used for XSS? Does it save the chat into a database? Could there be an SQL injection problems there? So each part of the planning should also take security into consideration. All right, we wrote the code. Now let's scan it. Let's test it. Let's use static application security testing. Let's use SCAs. Let's make sure that what we wrote is actually verified. We're building. All right, so this is container security, packages. We want to make that sure that everything is fine. Tests, right? So tests, let's use DASTs, web scanners, whatever we need to make sure that runtime is also working. And this way, in each part of the DevOps cycle, we have some kind of automation that is AppSec oriented or security oriented and just enhances the whole prospect. So what are the key principles of DevSecOps? First is shift left security. This is something that a lot of people are talking about, but what does it actually mean? So shifting left means bringing security closer to the developer, right? Shift right, or the right side, is production. The left side is developers, right? The code. And we want to bring security as much to the left as possible because that allows us much quicker iterations. Think about the difference between writing a line of code, finding a vulnerability there, and then fixing it directly there, instead of finding the vulnerability in production and then needing to figure out why it's in production, who wrote it, which part of the code was responsible, and you just need to reverse engineer your steps until you figure out where it was. So understanding or getting those alerts, notifications, findings as left as possible or as early as possible gives us a lot of advantages. Automated security testing. Now that we have the ability to integrate into the CI/CD pipeline, into the SDLC lifecycle, it means that all of those automated tools that DevOps added to the development process can now be used for security. Not all of them, but we can add tests, tools, and security automation concepts into the SDLC. So things like SAST, SCA, DAST, all of those automated tests can now be run inside of the CI/CD cycles, failing, letting it pass, depending on what we configure. And of course, empowering developers. Now, in the sense of empowering developers, we want to make sure that the developers can be self-sustaining in regards to security. You're a developer. You're writing your code. You know how to fix your own bugs. Why can't you fix the security bugs? In the end, security issues are just bugs. Maybe they have a different category, but they are bugs in the code. Someone can do something that was not expected, or your application behaves in a way that you did not think about. This means that you as a developer can now understand what has happened, because you got training, because you went through the planning, because you got notification about finding it very early in the process, and now you as a developer can take care on own security, which is a very cool concept. So the classic DevSecOps paradigm basically looks like that. So in the development stage, we're doing static application security testing, or SAST, which means running through the code with an automated solution and look for vulnerabilities. We have open source verification, or SCA, software composition analysis. I'm sure that a lot of you are using those without even knowing. So I'm sure you all know what Dependabot is, or you updated or installed NPM packages, and then suddenly NPM said, those packages has critical vulnerabilities. That's SCA. Or Sneak, or any other of those vendors. Security training, because we wanted to put the security already in the design or planning stage. So we want to make sure that developers know what to look for or how to think, right? Because it's a mind shift. We're not just thinking about functionality. We're now thinking about security in that concept. Now, in the CI/CD itself, we can run container analysis. We can run infrastructure as code testing. We can do all of those tests and checks, even SAST and SCA, but inside of the CI/CD build. So even if it didn't run on the development flow, at least it runs in the CI/CD itself. And post-build, we can do things like full web security analysis. So a DAST solution, we can run vulnerability assessment and if needed, we can even do penetration testing, but either automated or after splitting our lanes into a fast lane and comprehensive lane, we can say, you know what, this is the major build. All of those are just small fixes. We will do manual penetration testing on this very large generic build, and on the small changes after code freeze or whatever, we will only do automated testing. So this gives us a lot of options and a lot of capabilities on how do we plan our SDLC and how do we want to plan our development cycle. Now, when we're talking about AppSec or AST, which is application security testing, we have, I would say, 4 main tools out there, but let's talk about 3 of those. So one which isn't here is SCA, the source code analysis, which we talked about before, the software composition analysis. Others are SAST, which looks at the code and finds vulnerabilities in the code. We have DAST, which is automated web scanner. So basically scan the running application and get information, get results, and get which request, payloads, etc. we found. And IAST. IAST is interactive application security testing, and it basically supposed to be a combination of those 2 concepts, but we're going to talk about it in a second. So SAST is aimed mainly at developers. It runs in the IDE, it scans the code when you're doing your coding phase. The pros, of course, are early detection, but the cons is that SAST solutions are usually blind to the full picture. Because today's software is very microservice oriented, and a lot of the code that we work on are very small and very small pieces, and sometimes we can't get the full context of which requests come from where. Is this an internal API, an external API? Does the user have access to this? Is the information that I'm getting already escaped or not? Is the data, I don't know, flowing internally? We don't know how to answer all of those questions or provide SAST solutions with all of this context because, you know, it just looks at the code, not the runtime. Then it has a lot of false positives, and also it needs to do a lot of guesstimations based on a lot of information. Then we have the DAST approach. The classic DAST usually looks at security or AppSec people. And you should run it in the testing or staging phases. So the pros is it has full view because it scans the run live application. So all of those microservices and little functions are already all combined, or all of them are in the same flow. And it looks at it like an attacker would. The cons is that it needs a live target. Why is that a con? Because if we're talking about automation and we're talking about running stuff in the CI/CD, not all situations allow us to actually start a full environment inside of the CI scope. Some places we can do that, especially if it's just a standalone microservice. We can do Docker Compose, we can automate the deployment into a Kubernetes pod, or we can just, run something locally and then test it locally. But if our application is very complex, it has like 20 microservices that needs to run in the same time for it to be operational, then obviously that's not something that we are going to do inside of the CI. And so in those cases, that would be either a post-CI or a post-deployment or pre-prod, and you will need to think like, how do I actually position it? IAST is aimed mainly at QA or the QA phase. Why? Because IAST works by running introspection. Basically, it runs together with your run live application, and it does tracing of which requests or which operations or which functions in your application are being ran. And then based on that, it will generate the findings and all of the risks that it thinks that you have. So when you think about it, it sounds like the best of both worlds. You have the run live application information. It also does introspection, so it can point you to the code. The thing is that you also get the worst of both worlds. You need a run live application, but also you need to make sure that your IAST can actually introspect your code, which means it has to support all of those frameworks, all of those languages. And it also has to have some kind of initiator, right? Something that will cause the application to execute those requests, those functions, and let it run. So those are your main tools. And that's what usually you will find out there. Now, we're talking about the future of DevSecOps. So obviously, what we want to see, AppSec in the hands of developers. So we want to bring AppSec as close to the developer hands. For example, modern DAST solutions actually, and modern, I guess, SaaS solutions have the ability to really do deep integration into developer land. So, for example, modern DAST solutions might have the ability to do IDE integrations. They can run much quicker. You don't have to wait for stuff to really get deployed or run in the CI. And we can do even more push left. Auto-generate security-oriented unit testing. That's something pretty cool. So basically, you already have unit tests, right? You write your code, you add unit tests, you add integration testing end-to-end. Think about an application security solution that's going to auto-generate security-oriented unit testing. So that will be very cool. Full CI/CD automation. A lot of the things that we talked about is half there. So a lot of the organization, and I'm talking with many very high profile organizations out there. So not even top 500, I would say day to day, top 250, top 100. And they are not there yet. If we're talking about full CI/CD automation, there's always, this team does that and this team does that. This team uses a SaaS, but this team likes to use Elixir, so the SaaS doesn't work for them, so they're only using a Dust, and this team doesn't have the capability to run their solution in the CI, so they can't run a Dust, so they only run. So if we get to a place where we can do real full CI/CD automation, that is also going to be pretty amazing. Immediate feedback of detected issues, so bring us fast remediation. So think about just running your line of code, or just, I don't know, save, or just git commit or git push, and bam, you have already information about, listen, there you just uploaded an issue, or there's a problem with your code, or get those feedbacks as fast as possible, and actionable results, right? So there is a concept that I mentioned before just in a bit, which is false positives. False positives kills productivity. It's a concept that we call alert fatigue. But basically, if you generate 5,000 findings, no developer is going to look at those findings. So we need to make sure that each finding that we generate is going to actually be actionable. It's going to be true. right? So this is part of it. So as accurate as you can get with the tools, that will be perfect. And that's about it. Thank you.
Okay, thank you, Bar. Very, very interesting. I actually learned several things, I can tell you. And guys, if you have any questions to Bar, please write it down in the Q&A. So Bar will answer all your questions. So we have several questions on the line. I will read it out loud.
Mhm.
So the first one from Anonymous, if we were to start from nothing, what is the best next step after getting buy-in and collaboration with the developers and DevOps team? What will be the first steps, Bar?
So the first step in the sense of implementing new DevOps procedure, or in the sense of implementing new DevSecOps procedure. So
So I
if we're
think
talking about,
starting with the DevSecOps, I think
yeah,
starting
yeah.
with the tools, the security tools, what will you start
So
with?
so if we're talking about starting a new DevSecOps process, I would say get the basics. So first of all, make sure that you have an SCA, because those are the quickest thing, and there's a lot of good open source tools out there. So SCA as first thing, if you don't have it already, put it into the CI. Make sure that no Git commit or Git push can actually be passed without software composition analysis, without package analysis. So dependable if you're using GitHub, or you have a lot of like options out there. I would say that the second thing is to try and get a Dust solution running. And that's because you want to at least see what you have in runtime. And SCA won't be able to tell you what you have in runtime, and SAST also won't give you the ability to see what you have in runtime. So get a Dust. Then, I would go with maybe SAST, infrastructure as code, and container security, depending on how your application looks like.
Okay, interesting. So Bar, as I understand you, it's like the DevSecOps, it's like a defense in layers. So you
Mhm.
are building several defense. If someone will be broken, then there is additional layer that will protect or reveal security defect. Is that correct? That's the approach? That's
Um,
the right.
so everything about security is layers. As we all know, security is like onion, and we take into consideration that at least a few of them are going to get breached. So we want as many layers as possible to make sure that we catch it somewhere. I would say that in the case of DevSecOps, is more about making sure that you cover everything. I guess it's also layers, but it's a coverage kind of situation. So we want to make sure that each part of the application, and that means third party packages, source code, infrastructure, and also like the operating system that we're running our software on. So container security and runtime, so Dust. So we want to get all of this large view available.
Mhm. Understood. Okay, so Mohit is asking, a very serious question. Uh, why is it called DevSecOps and not SecDevOps? This is a historical question, so if you can
That
highlight
that's
this.
actually it's a it's a funny question. The point is to put security in the middle, right? So that was the idea. So it's like you take dev ops, you move them aside, put security in the middle. That's basically why.
Connecting between the ops and the dev.
Exactly.
Understood. Now it's clear. Okay, Dennis is asking, what about external libraries? I assume he's talking about third-party components.
Hmm.
And he's saying like you cannot be 100% sure that those libraries have no vulnerabilities in the process. How could you be sure of that,
So
Bar? What is
so
your...
this is exactly why I said SCA should be your first stop, because software composition analysis, or SCA, looks at the third party code, at least on your code, you can do some kind of evaluation. But the code that you take from someplace else, that's the riskiest part of your code, because you are never 100% sure what there is inside, which is why you should put SCA as the first thing. So that makes sure that your packages are up to date and have no known CVEs.
Okay. Okay, interesting. So there is another question. What is your take on eliminating issues early on using strong SAST? Will it reduce the effort spent in the right side of the, I assume in the CI/CD, not the or the SSDLC?
So the obvious answer would be yes. The problem is that SAST solution have a lot of tendency to generate a very large amount of false positive because of the guesstimating that I talked about before. And that can cause alert fatigue and a situation where your developers just doesn't believe in the tools. So even if you go with SAST, I would say use a Dust solution or a runtime scanner to validate the result of the SAST before you give them to the developers, because otherwise your developers will say, you know what, we can't handle those 10,000 findings and it's not actionable. We need to make sure that everything is developer friendly, and that means the least amount of noise that is possible.
So you are considering SAST as something that make maybe more noise if we are comparing it to Dust, just for
That
context.
yes, because Dust has the possibility to actually do validation.
Mm.
SAST, when it finds something, it will at best say, you know, we have so let's think for a second how it works, right? So we have a code, we have a function. This function called save data to database. So we take some value and save it in the database. Now, we don't know where this value came from. It could have come from an internal microservice. Maybe it came from a user. Maybe we already did a sanitization in another function or another microservice on this data. The SAST can't know it. It can't get the context and full view. And that's why the SAST will say you have an SQL injection here, but then the developer will tell you, no, there is a full microservice we have which sanitize all user input. So here can't be an SQL injection. And in this case, Dust just won't trace it because it won't find it. It will try and attack the entry point, see that there is no SQL injection. It will just won't waste your time in that case.
Oh, that's reasonable, and of course, very straight looking forward how to mitigate the risk, and of course, it's coming from best practices, and common knowledge as you are familiar with the companies that you are working with. Okay, so there is another question from Dennis. Dennis asked us to imagine you did everything perfect in terms of DevSecOps. You publish your apps in production, and then suddenly you found data leakage. What would be the steps to fix the bugs? So stop production until the bugs will be fixed, or hope that nobody will know the problem? Like, what are the best practices as part of the DevOps team, the DevSecOps
Yeah.
approach?
So I would say that usually the CISO of the company will need to do the evaluation and decide on what should be the right approach. Obviously, hiding the problem is never a good approach, but most likely taking down production to fix a security issue is something that no one does. So that's the power of DevSecOps, right? So we find this problem in one of the steps. Now we know that it's also in production. We have a very quick way to just send an update, test it through, and deploy it. And that can be, a Docker image update. That can be an automated deployment script. But we have the ability to do those fixes very quickly and get into a situation where it's not a big deal to update, to do those rolling releases, those live updates. I saw a lot of cases where companies just will, hotfix those things. And it's like, I have a critical issue in production, we're just going to hotfix it. So it's like 2 hours and it's out, because we have all of this automated testing, automated verification, and GitOps in a lot of cases that allows us to do all of this workflow automatically.
So take into advantage the DevSecOps approach, the DevOps approach, to go to production very fast. And I think we as a security professional need to understand that we can take it into our advantage and to fix security issue very fast. I saw it happen. I saw there are lots of security risks and security defects which is found. We always try to find them before production, but most of the time, yes, we find security defects which is in production, and now we need to handle it, fast deploying it. There are some security risk mitigation that you can do from application security point of view. This is also some aspects outside of the DevSecOps. You can also deploy it like a web application firewall, a WAF, or some other mitigation or control in order to mitigate the risk until you fix it, testing and fix it, of course. But this is approach that the industry are going to, and I can see a very fast deploying of security defects. So of course take into consideration also
DevOps for the win.
Yes, that's what they are doing. Barry, in your day-to-day work, are you working with the DevOps team, more DevOps team, or more R&D teams? What are the
so in our company, those teams are actually all under R&D. So R&D also encapsulates DevOps. So DevOps and development will always work together. We have like engineering and DevOps, and everything we do is somehow combining most of those both of those teams. Now, I don't know, something cool. So for example, our company needs a lot of practice targets, right? To test our solution, to see that it finds all the vulnerabilities that it scans. So we need a lot of targets very quick. So with that, how do we automate getting practice targets up so that we can test them and, in an automated way to put it into the CI/CD, because you need to spin up, for example, Juice Shop. You need to spin up broken crystals. You need to spin up all of those vulnerable applications to do those tests against. So our infra team or DevOps team basically said, you know what, on us. So they created this awesome bot in Slack that we can just tag, ask it to spin up whichever application we want, and now it's part of the CI, and it's amazing. And all of the developers were like mind blown, because before they had to start running Dockers or asking for VMs in AWS, and this is the perfect example of how this infrastructure team or DevOps procedure actually brought infrastructure to say, let us help you, to the developers, and the developers can now run in a much quicker pace thanks to that.
To fix security issues.
Exactly.
Right. Okay. It's all about solutions. It's all about solution.
Exactly.
And I think I can see in the day-to-day that the DevOps team is a team which can assist to implement security better in the pipeline, in the development process, because they are actually managing the tools. So they are managing each and every steps in the pipeline. They can insert security tools as part of the pipeline. They can give you insight because they are technical guys. So together you can build the right solution for you. Take out of the shelf, don't invent the wheel, but integrate it in your CI/CD, do the fine tuning, and of course deploy it accordingly. But thank you very much for very insightful lecture and answering all the questions. Thank you very much for that. It was very insightful. So without further ado, I do want to continue, but Rotem is waiting, eager to start his lecture. I do want to introduce Rotem Rice, who is the director of product security at Playtika. He also was or still now experienced full stack developer. However, he shift the side to security, so he knows all about the developers, and now he's a breaker. Let's call it breaking the code, not building it. Rotem, is that correct?
Yeah, I agree to that. Yeah, I'll take that.
Okay, but he's also continuous hardening, doing security audits in his company, and also application hardening and system administration. Guys, stay tuned and hear what Rotem has to say related to risk-oriented in the DevSecOps. So, Rotem, you have the control.
Okay, cool. Thanks, Lior. So I must say before I even start about the last question that Dennis, I think, asked. So there was a big problem with his question, in my opinion, because he said, imagine you did everything perfect. So security can never be perfect, and security is a feeling eventually. So we need to bear that in mind always. So I had to say that, and now I can actually start. So first of all, hello everyone. I'm super happy to be here and speak about our approach at Playtika for risk-oriented DevSecOps. I see some people from Playtika here in the webinar and the meetup, so hey. Okay, so you will find some similarities actually to what Bar talked about. You will find a lot of similarities, but I think that we are both attacking it from two different angles. So I think that it will be interesting to see now my view on that. So let's start. See that it works. Okay, cool. So I'm leading the product security activities at Playtika. I'm also, as Leo mentioned, shifted from software development and DevOps to application security a few years ago. I'm also contributor to multiple open source projects and also a bug hunter on my spare time. So as you said, I like to break things. I think that this is like an integral part of the work of protecting something. You need to know how to break it. I'm also responsible for multiple CVs and also helped securing some well-known companies like Microsoft, Yahoo, products like Elasticsearch. And last, I co-organized the first Israeli bug bounty community meetup together with a colleague of mine. So that's mostly about myself. So let's start. So we want to spice up our cyber. Eventually, companies want to establish an application security program, and that was one of the questions here in the chat. So how do you even start? And I think that talking about DevSecOps, in order to talk about DevSecOps, you need to understand, first of all, what DevSecOps is. And Bar, as I said, presented his approach or what he think about DevSecOps, and I totally agree. Eventually, this is the triangle between development operations and security, and you need to have good vibe, let's say, or good communication with both sides to in order to actually do something productive, I think. So let's see how we can start. Like every good presentation, I could show you some quotes about how outnumbered we are as application security people, but eventually let me skip all that because we all know that. This is why we are here to get some tips. But there is one quote that I'm not going to skip, and this is talking about fun. So eventually, in order to establish a good AppSec program, you need to have fun during the process and all along the way. If you're not having fun, or someone that is involved in a process like R&D teams, DevOps teams, so you need to stop and understand how you need to change stuff in order to people to have fun, or at least try to have fun and not to suffer during the process. So that's highly important. Eventually, we want to make good communication with the other teams. Otherwise, it will be security and not DevSecOps. So bear that in mind. So now if we will look at how an AppSec program looks like, and this is only a practical of what we actually have in this enormous iceberg. So we can take a look at things like WAF and API security, SCA, secure code trainings, SAST, IaaS, DAST, all the things that Bar also talked about. And in the top of the iceberg, we can take a look at penetration tests and external attack surface management, bug bounty program, things like that. So how do we start? And I must say that it's not that helpful that vendors be like, pick me, I have the best security tool that will make your company more secure. So it's not helpful, stop doing it. How do we start? So I believe that we need to make an informed decision making, and no one knows your company better than you. But you need to ask yourself a few questions that will help you to get the right questions. And I gathered a few questions that you can ask and that will help you to understand where you need to start and where you need to focus. So first of all, how many applications you have in the company. So this is completely different if you're trying to protect a company with one product, or if you're trying to protect a company with 15 products or hundreds of products. Eventually, you need to work with different technologies, different frameworks, and that's much harder. How many developers in the company? On some companies, you might have 20 developers and you're sitting next to them. And on other companies, you are working with developers all around the globe in different time zones. And in the case of developers next to you, you can just go near them and do some live code reviews and things like that and training sessions. So that's, again, different between company to company. How does the CI/CD look like? On some companies, you will have one single pipeline where you can put all your security tools inside, and that's easy. But on other companies, you might have a lot of CI/CD pipelines. You will also have some case of legacy software that you don't even have a CI/CD pipelines. So again, that's all different story. What are the crown jewels? And I think that this goes end by end with compliance requirements. So if I need to comply with GDPR, SOC 2, or even PCI, then it's a whole different story than not complying with all those. And by the way, there was another question about what do you do about a security breach? So eventually that highly depends on which compliance requirements do you have in your company. And then you understand what do you need to protect. Do I need to protect the data? Or I don't know, transactions of payment transactions, things like that. Who do we report to? This is also something important. Do I report to the CTO, to a VP R&D, to maybe IT? If I'm reporting to the IT, then it will be much harder for me to have any leverage on R&D teams and tell them how they need to work. But as opposed to the case where I'm reporting to the same VP R&D like them, and then I just go sit by them and he backs me up. Okay, so again, it's also important. And last, what are our weak spots? So I need to understand what are the main risks that I need to tackle, and that will also allow me to focus better on where to start. So I'm going to share the happy path, at least how it was for us at Playtika, and I think that it was happy eventually. So I say, forget all the buzzwords, and especially shift left. Shift left is good, but it's not always the answer, or it's not always the first thing to do. So it's cool to take static analysis tools and dynamic analysis and put all those in this CI/CD, but eventually it will take a lot of time, a lot of effort. It will have a lot of noise, a lot of frictions with different teams, and it not might be the first thing to start with. So I'm saying Wombat your way to a scalable AppSec program. That's an acronym for where are we, outline your assets, mitigate low-hanging fruits, build a responsible disclosure process, assess and protect weak spots, and track your security tickets in one place. And I know that it was fast. We're going to go over each and every one of the bullets, and then you will understand what I'm actually saying. So I'm going to show you how it's done. So first of all, where are we? What do I mean by that? So as I said, on my spare time, and also most of my team on their spare time are also active bug hunters. So that means that we also know how to break stuff. You can't actually protect something without looking at it like an attacker. So this is why I think that starting from static analysis isn't always the first thing that I would do when establishing an AppSec program, because I would wear my hoodie and I will try to attack the company, my company in this case, and try to understand what are the weak spots that I need to cover, what are my findings, and on a lot of cases, it will indicate where do I need to focus at the beginning. Next is to outline our assets. So in this case, we will need to have some mapping of what we have externally exposed. So also internally, okay, so things like an internal back office systems are also important. But for start, at least, we will start from the outside to understand what is exposed and what is putting us at risk. So in order to do so, I'm going to present a few, and not only this specific thing about the outline your assets, but about all the things that I mentioned, all the Wombat thing. I'm going to share a few open source tools. Some of those we developed, some of those are publicly developed by other people and other companies, and you can start using them even today. So that's important. And if you have any question about any of those, feel free to reach out afterwards. Some of those are in our Playtican GitHub account. As you can see, you have it in the title. So let me just proceed. And if you can't find it, let me know afterwards. So the first tool is called dcollector. What it does is fetch names from various sources like Amazon AWS Route 53, GCP, DigitalOcean, and Prisma Cloud by Palo Alto. Eventually, it goes to the cloud providers. It fetches all the DNS records from there. It creates a unified structure of all the DNS records that we have. And then we are good to go because we have a good list of all the assets that we have at the company. By the way, on the right side, you will see which phase am I talking about. And in this case, I'm talking about the recon phase, the reconnaissance, but I'm also going to talk about the scan and remediation phases. So after we have the domain list, now we want to gather some URLs because eventually most of the bugs or the vulnerabilities won't actually be in the root domain itself. So how do we do that? We are doing it in two different ways. One is use an open source tool called GAO. GAO is acronym for Get All URLs. This is a great open source tool that actually gets URLs from places like Alien Vault and the Web Archive, things like that. And the second way is to fuzz URLs from common word lists, like any of us that did some penetration testing in the past knows. So this is how we actually cover some URLs and we are good to go. The next thing, once we have all the URLs, is that we want to actually start mitigating some low-hanging fruits. Why do we want to do that? Because again, we want to look at our organization like an attacker. Eventually, what they will do, and most of the script kiddies do, and also a lot of hackers are, on most cases, lazy, and I think that in most cases, they are not actually targeting your organization specifically, but they are just spraying their payloads until they will find a victim. They will put some ransomware on their systems or a crypto miner, things like that. So eventually, we want to mitigate all the low-hanging fruits and scan it just like any attacker will do. So how will we do that? So we have an internal tool this time that is called Enant. Enant is actually just a wrapper for the open source tool called Nuclei. If someone here doesn't know Nuclei, this is an open source vulnerability scanner by a company called Project Discovery. This is a great tool. What it does is to have a lot of templates based or written in YAMLs. And eventually what it does is to scan for vulnerabilities, misconfigurations, CVEs, all those. We are using it and running it with multiple periodical scans. We actually have scans that run every few minutes. We also have another scan runs daily and another one which is run weekly. So we have a lot of different periodical scans, depends on the severity of the findings that we are looking and the commonness of the vulnerabilities that we are actually hunting. And we also contributed to Nuclei as part of the project. We contributed multiple templates and we are keep doing it. And it integrates to our Jira using another tool that I will speak about in a few slides, which is called JTrack, something developed by us. And this only an integration layer to Jira, let's say. The next tool is called CXSS. This is another internal tool, which is another wrapper for an open source XSS vulnerability scanner called DalFox. This is also something that we run periodically and integrates to our Jira via the same tool, JTrack. The next one is something that we open sourced, and this is a pretty cool tool that I believe that we open sourced. I don't know any other tool that actually does exactly what we do here. What it does is to find dangling domains. It's called DDFR, Dangling Domains Finder. And we all, or most of us, I guess, know what subdomain takeover is, but dangling domains is a much harder issue to detect, because let's imagine the case that we have a DNS record that is pointing with an A record to a subdomain pointing to an IP address. And this IP address was belonged to an EC2, which was belonged to us, but now we released the EC2, and this is now pointing to an EC2 that doesn't belong to us or to no one, or on another case belongs now to another company and could have some vulnerability. So eventually this is kind of subdomain takeover, but it's much harder to detect because you need to understand if the IP belongs to you or not. In short, what this tool does is to get all your DNS records from, again, the collector, like I mentioned earlier, and also all the organization known registered cloud IPs, and then it creates the correlation. And if there is an IP address pointed from an A record that doesn't belong to us, it will raise a ticket. Okay, so that's about it. Another one, and we're almost done with the tools. I know that this is like a lot of tools, is WordPress Scanner. I don't have a lot to mention on that. Also, it creates Jira tickets automatically, and that's mostly it. The last tool that I'm going to talk about is Lictopus. What it does, and by the way, I presented it in B-Sides Tel Aviv 2 years ago, it can identify code leakage that is belonging to your company. So in case that one of your developers leaked a code on public GitHub, this tool will be able to hopefully identify that and let you know about that. In our case, it's integrated to our SIEM. So once we identify a code leakage, it automatically raises a ticket to our SOC that are investigating the case. So next, I'm going to talk about build a responsible disclosure process. This is also important and very important in my opinion, and one of the first things that you need to do in a company, because in a lot of cases, security researchers want to contact you after they found something, maybe even by mistake, but they can't reach out to your company, and that's not good. So on a lot of cases, people think that they need to pay money for having responsible disclosure program, but I'm saying that you have two options. You can choose the zero budget option or the paid alternative. What does it mean? On the zero budget, what you can do is to create a free vulnerability disclosure program, like an online page that publishes all the information how to contact your security team. And the second approach, which is even easier, is to create security TXT and humans TXT files in your branding website, like you can see here in our public website. And then it says, how can you contact the security team in case you found something? And also we acknowledge white hat hackers that reported security vulnerabilities to us. So again, this is free. You can just go ahead and do it now. Nothing too fancy, and you can take the example from our website. Regarding pay alternatives, you can have three different options. The first option for a bug bounty program is an internal, and by internal, I mean to your internal employees. This won't work for a company with 20 employees, but it will work perfectly to a company like us with 3,000 developers. And that means that if a developer identified a security vulnerability in one of our applications, they will be able to report it and then to get monetary rewards on their report. The best thing about it is that developers, in a lot of cases, have some internal insights on how things are actually working, and they will be able to identify more security vulnerabilities than what you will be able to find from the outside. Of course, there is a policy to that. This doesn't mean that I, as a developer, can create a backdoor and then report on my backdoor. So there is a policy around that, but eventually it is great. I must say that we had some doubts at the beginning when we started, and we started it much way before the private program that we have. And we identified some, I think it was a few critical vulnerabilities, including RCEs that affected production. So it was great. And I deeply recommend that you will do that. Another option is the private or public program, like on known platforms like Bugcrowd, HackerOne, and etc. Next, assess and protect your weak spots. So until now, again, we discussed about the low-hanging fruit and how to outline all the assets that we have. Now we need to be smarter and to understand what are actually the weak spots that we have at our company. So let's take a few examples, how I can actually focus my program on the right stuff. If I'm developing a SaaS platform with various integrations, then I can almost surely say that I need to be more resilient from SSRF attacks because, again, I have a lot of integrations to the outside. Another example is that as a multi-tenant and multi-roles SaaS platform, I will for sure want to be more resilient against broken authorization vulnerabilities. And in our case, as a gaming company, business logic vulnerabilities are something that we care about more. And I will give you just one example. Imagine that you have a slot machine and you can spin the slot machine once. I want to make sure that you can't spin it more than once and get this twice as rewards. Okay, so everyone with their own weak spots and their own risks. And you know your company the best, again, and I said it before, and I will say it again. Another thing is to track your security tickets in one place. So eventually you ended up with all those checks that you have in the way, and you have a lot of security tickets, but you want to track it in one place so you will be able to prioritize it correctly and to get more statistics on what you're doing. So how can you do that? As I mentioned earlier, we have a tool that I actually developed called JTrack. What it does is just anything to Jira integration eventually. So it doesn't matter where what is your scan or what do you want to open in your Jira, but eventually you can connect anything to Jira with a simple CLI command. It's available on GitHub, and eventually the secret sauce about it is that it is managing and tracking the ticket's state, and this is the hard part, so I won't open the same ticket over and over again, so it just manages the state of the ticket. So this is part of the remediation phase. Now, let's take a look at the whole picture for a sec. We call all the stuff that I just mentioned continuous recon. And it starts with the collector that gets all the domain names. And then we are getting only the external domain names. And we are scanning it with various tools like Enant, CXSS, DDFR, and WP Scan. Then we open Jira tickets if we found something. And you might think that we are not actually using an external attack surface management tool, but you are wrong because we do, and we are enriching both sides. So the EASM product that we have enriches the domain list that we have, and also dcollector also enriches the EASM product that we are using. So there are some advantages of still using such a product, so we are using both. Okay, but wait, what about retests? So we found so many bugs along the way, but let's imagine that I have identified a misconfiguration vulnerability and that one of my Nginx servers exposed something publicly that it shouldn't have. How do I know that a day after it was fixed by the DevOps and the Jira ticket was closed, that it's not actually opened again? So this is why we ended up with the concept of regression tests on security. So the purpose is to have a feedback loop of automated regression tests, and once a regression has been introduced, we will automatically open Jira ticket and make sure to fix it again. What was the motivation for that? First of all, developers now have a clear acceptance criteria of what they need to do. So they don't need to guess what should be the fix, because eventually, once we've identified a security vulnerability, we automatically create a nuclei template in our case with the check to identify the vulnerability at first it of course fails because we still haven't fixed the issue, and then the developers knows what to do in order to fix it, and it reduces the manual retest efforts that we need to put from our penetration testers, because again this is now done manually, automatically. So you might ask yourself, do you automate everything? And the answer is no, we don't automate everything. What we automate, and the two main rules that we have for what is aimed for automation is, first of all, is it easy to automate? And the second, is there high chances of regressions? For example, things that we do automate is, like I mentioned before, the Nginx, and in general, unintentionally publicly exposed endpoints or data. This is a great example of what we do automate. How does it look? So in short, we have a single code repository of custom nuclei templates that we build. And once a developer fixes, or an operation person fixes a vulnerability, the regression tests are keep running once a day. And when we identify a regression, we open the Jira ticket once again for the team to fix it. This is how it eventually looks like, just a simple YAML template. And since it is so simple to create YAML templates, we do give security champions also the option to contribute, pull request, and to contribute some of the regression tests. So it's not all on the penetration testers to do. As I said, it is being executed once a day. So now, after we are done with all the right side, let's start shifting to the left side. So we wanted to shift left, and as Bar said in his presentation, we can't go back to waterfall on one case, but this is not something easy to actually become agile as R&D teams, but we wanted to do that. And this is why we asked ourselves and created a few constraints on what needs to be done in order for us to actually be able to shift left. So the first thing and the first constraint that we have is, or the first question, how and when should we know about new features? How can we identify risky changes in real time? How can we shift left and test features as early as possible? And this is an important one, while keeping the business running at the same velocity as before, because we don't want to stop the business and again bring back waterfall. It wasn't that successful and times has changed. Eventually, traditional penetration testing is not something cost effective, and on a lot of cases, a day after the penetration test was done, the developers will release a critical vulnerability to production. So not only a critical feature, but also a critical vulnerability, and we want to stay ahead and know about it. Another question is, how can we cover a wider attack surface with the same means? Eventually, I can't go to my boss and say, okay, I need to double the amount of people that I have in my team, or to double my budget. It won't happen. So I need to work with the same means. So what did we do to make it happen? First of all, we treated all the software architects that we have at the company as security architects by design. So we had meetings with them and training sessions to make them more aware about security. We worked really close with them on all that. They are also now creating and doing threat modeling as part of the high-level designs that they are preparing. And in case that they need to have a second opinion, if they are working on a risky feature, then they can contact us. We will go over the HLD that they are doing, the high-level design, and we will give our feedback for how can it be improved. We also have steering committees with various business units. That means that we are meeting each and every one of the business units once every 6 weeks to go over all the open vulnerabilities that we have, to see on which new features they are working on, and to give our feedback and to be involved in those places. Another cool thing that we did is to work close with QA teams. So QA teams are like siblings of AppSec eventually. So we wanted to integrate ourselves into their process. And usually what QA team does is to create user stories. What a user story, or scenarios to test user stories. Eventually what it means that if I need to spin, or as a user, I want to spin a slot machine once and get a reward. So we are creating also, and QA teams are now creating abuser stories. So as an abuser, I'd like to spin the slot machine twice and get twice as rewards. And eventually what it makes them is to think more about security earlier in the process and identify business logic issues that are very hard to find with Dust or other means. So that was something really effective that we did. But again, this is mostly about talking and manual process. So we wanted to have something more automated and to make it even more wide, let's say. So what was the motivation? I guess that it's pretty something that we can all understand. Eventually, what we decided is that we want to focus on risks and not only on vulnerabilities. And we wanted to identify the risks earlier in the SDLC. And we made it under the assumption that risks often lead to actual vulnerabilities. And again, as Bar said, vulnerabilities is something that we have a lot of, and there is alert fatigue eventually, especially from tools like Dust, SAST, and all that, those. So we want to have vulnerabilities with context. So we don't want to look at a SAST finding by itself, but only on a SAST finding if it is deployed to production and is actually running. Just one example. Also to continuously look for risky changes. And we're going to talk about what is a risky change in a sec. And eventually we wanted to fuel our penetration testers with precise and impactful challenges. So they won't need to retest the same application over and over again each time that we are releasing something because it's not feasible. We are releasing new features to production multiple times a day eventually. And by the way, challenge is how we call a mini penetration test in our case. It could be a penetration test on a new API endpoint, on a complete back office application, or on a specific feature. So how did we do that? How did we start? So first of all, we did some brainstorming and we understood and we said that everything is possible. Let's start to think what do we want to actually find and what is a material change. And we also did some retrospective on known vulnerabilities that we had in the past to identify the material changes. And once we found the common ground, we went back to reality and looked at the commonness of the vulnerabilities that we identified. What was the impact? Because we don't want to focus our efforts on something which doesn't have a lot of impact. And how difficult will it be to actually implement it using an automation? And we ended up with something like that, with a table. So let's take a few examples. So we had the material change on one column and the priority and effort. For example, one material change is internal API that is now exposed publicly. The priority of this one is high because it could lead to high impact issue, and the effort is medium because this is not that hard to automate. Another example is a change in content security policy. The priority is medium because eventually this is an hardening layer and not a vulnerability by itself, but the effort to implement that is low. So we might want to also do that. You have a few more examples here, but I'm going to skip that. So let's take the first real example that we actually implemented. And I'm going to present it in the way of given, when, then. This is like a good way that QA teams usually do to describe QA scenarios. Given a PR, a pull request is opened, and when a new API route is introduced or modified, and when the route is processing user input, when the user input property name is prone for unintended behavior, for example, URL to SSRF, and redirect URL to Open Redirect. I'm going to explain what it means because it might not be that understood. So let's imagine that I'm adding a new API, and this API has a new attribute, or it could be a query param, or in the body, another param that is called URL. Eventually, what we know from our experience as security professionals is that in a lot of cases, a parameter name called URL could lead to SSRF vulnerability. Redirect URL often leads to a vulnerability of Open Redirect. So what we want to do in this case is to place a comment in the pull request to tell the developer, to give them kind of an insight, to tell them, you know what you're doing? Did you make all the input validation that you need to do? So just to raise the awareness. and then also to require a security review to create a challenge to our penetration testers to actually check that we don't have any actual vulnerability in that. This is how eventually it looks in GitHub to the developers. This is their developer experience. In this case, we're saying a product security GitHub app found a potential risk. Note that we are talking about a potential risk and not about a vulnerability in this case. The parameter name CMD is commonly associated with RC vulnerabilities, and we're giving them some links to read more about that. I'm going to skip this one. Actually, this is not the updated presentation, Leo. So next time. The second example is risk-based approach. Of risk-based approach is given a PR is opened, and when a content security policy is changed, then we want to create a challenge for the team. Another last one, which is, I think, more interesting about subdomain takeovers, is given a PR is opened when a URL is present, and when the URL is a takeable subdomain, then block the PR with a relevant comment. So we took something that usually companies do with their external attack surface management tool, and we shifted it to the most right side to the pull request phase. And this is how eventually this looks in the eyes of a developer. We are saying that the following URLs were found in code and are pointing to a non-existing S3 bucket. So that will make the developer actually have the S3 bucket before pointing to that from their code. In general, our vision for this approach will be to detect more material changes from more sources other than SCM. You can take some examples from API gateway, for example, if this now exposes something, or from cloud accounts that we have. Another thing is that we would like to analyze documentation, and this is even going later in the SDLC, to review high-level design and then to give feedback to the architects or to the product teams with some risky changes that they are introducing, and even more AI usage. So I'm not sure that I mentioned it, but the example that I showed with the parameters, the risky parameters, this is done by or with the help of AI, because eventually trying to extract all the list of endpoints from code and the parameters is something that is easy to do manually, and there is no tool out there that can actually do it automatically. So we used AI for that, and that worked like a magic. Just to wrap up, so we said that you probably want to create your own risky changes rules. Eventually, what I presented here is things that was common to Playtika, and things that we wanted to focus at. And we are planning to release an open source framework to create or to allow other people to create more rules. Shift left, but only when you are ready. Don't always start from shifting left. It is harder to maintain, and you won't always find all the vulnerabilities that you plan to use at the beginning. Use open source tools to map and attack your external attack surface. Eventually, we have great open source tools that you can use. Make sure that you have a full vulnerability management lifecycle, especially around retests, and that you know where you are tracking your tickets. On a lot of companies that I helped to, they had tickets, developers closed the tickets, but no one actually tested the tickets that it was actually closed. If you have any questions, feel free to reach out here and ask it. And by the way, you can read more about all the things that I presented here really quickly on our Playtika blog. Thank you.
Wow, what a presentation, Rotem.
Yeah, it was long, I know, and I squeezed a lot of things inside. So
I'm seeing it as a technical person. I can tell you that it's reflect a very high application security program. So all can learn from Rotem experience, and I truly believe that he's putting his experience in the presentation. If you will go through all his steps, you will receive a high level of application security. Of course, as Rotem said, you need to adapt it to your pipeline, to your development process, to your company business. So, Rotem presented Playtika and how they did it. However, you need to take and adapt it to your company and your development lifecycle. So, Rotem, thank you very much for that. We have just one minute to answer questions. So I will try to shift all the questions in order to keep up time. Ask your questions in the Q&A. If you won't have time now, we will stay in the end of the meetup and answer all your questions. So feel free if it's in the Q&A. I do want to mention something that is relevant to a question here in the Q&A. Most of the tools that Rotem presented are open source. So you don't need to have a huge budget in order to implement open source. It's free. You can download it. And also, Rotem, you're also publishing open source projects that people can download.
Yeah.
Okay, so that's very important. You don't need to buy a very expensive solution, or start with an open source and then continue to some license. Okay, so in order to keep up time, we'll go to the next presentation. Rotem, if you want, you can answer in the Q&A also digitally. So thank you very much, Rotem, for your presentation. Very insightful. I also learned, I'm taking notes and also taking it into consideration in my company. So very interesting. Without further ado, I do want to keep up time and invite our next lecturers, Eddie, which will talk about the cybersecurity balance. Eddie is a well-known cybersecurity professional. I will not disclose your age, Eddie, okay? So, but lot of years, I can tell you, from my beginning of my occupation in cybersecurity world, Eddie was already there, okay? So he actually established, just to summarize or to highlight, Eddie was the one who was a co-creator and also the chief security officer at the Israeli eGov, the e-government, which is the gov.il, also known as Tehillah. So Eddie, without further ado, please start your presentation. I'm giving you the control. So let me know if you can switch the slides.
How can I switch the slide exactly?
Just click.
Click? Yeah. How can I click back?
Just back in
Just
the...
play with the arrows, back and forth arrows.
Sorry.
Yes.
Okay. Hi, everyone. I'm Eddie Harari. Today I'm General Manager of Infinity Labs Cyber Division. Infinity Labs has a very elaborate program for programmers, developers, and cyber security personnel. And my talk today is more on the general aspect of security, but it's very relevant to any development cycle, because at the end of the day, we are all using the infrastructure. And my talk today is about security approach. And mainly because I see some, say, gaps between the way I view security and the way people approach it. And without further ado, I will start. First of all, about myself, my name, you all know now, Eddie Harari. If you look 25 years ago, I was going in the e-zines, the first hacking magazines. Some of my work is there under a nickname named the Gremlin. Most of the years, I think there was some other nicknames, but that was mainly most of the years. I have very elaborate experience with cybersecurity and many topics of cybersecurity on both the defensive and the offensive side. I learned cybersecurity in the army, and I worked through at the first 20 years for the government. The last 15 years, I'm working for the high-tech sector, say like that. So I think that any presentation today without mentioning, and it was mentioning, I think, in the last presentation mentioned a little bit of AI at the end. Am I correct? So I'll go, and I went ahead and I asked ChatGPT what is cybersecurity balance, and this was its answer. The answer is good enough, but it's not accurate. And I'm not going to read the answer, but yes, I'm going to explain what is cybersecurity balance in my view. Cybersecurity balance is deciding the risks that I'm allowing myself to live with. In many cases, and the best demonstration of such cases would be an organization, whether it's a development organization, like a product organization, or any other organization, gets hit by some kind of a ransomware. And all of a sudden, you see that this incident changes the approach, the security approach of the organization at the very same moment. And they start deciding to do things based on urgency, but not really evaluating the security and their assets, but because the decision making transforms from the level of the technical people to the level of the management, and they bring advisor, etc. Cybersecurity balance means that not every cybersecurity threat, and I'm saying it out loud, should be dealt with. Not immediately, at least. Because the cybersecurity is an ever-going war between, or ever-going balance between comfortability of your users, usability, business continuation, and many tasks that you do with cybersecurity may disrupt your day-to-day production life. And when I thought about it, when I was going to many customers, mainly doing some gap analysis and looking at what they place and how they build their infrastructure for the development cycle and how they build their infrastructure for the production, etc. And I saw, and I think it's mainly because the question is, what is better? Technology, when we talk about cybersecurity, which is better? The approach of using technology for cybersecurity or policy and methodology for cybersecurity? So of course the answer is both, but which one are we going to when we have a cybersecurity problem in our infrastructure or in our cycles? So I think anyone with a little bit of experience will answer that this question is not relevant to cybersecurity exactly, because of the reason that if to answer this question, you need to know what is the context this question is being asked about. Is it asked about off the grid, for example, military environment? Is it asked about connected environment? Is it asked about development environment? What kind of environment and what kind of problem am I coming to solve? But when you look at it, you see that people, especially hands-on people, tend to go to the technology part and neglect the policy and methodology part, and often enough it will give them less security than the desired. And I think technology gets more focused because of the simple reason that it's more it's more reachable. It's more interesting than starting and conducting policies and starting to design certain methodologies that will ensure security, and sometimes, by the way, better than any kind of technology placed. I think part of the problem where I see it is that a lot of products, and I heard the previous and the previous lectures, and the previous lectures definitely present, elaborate security processes in product development. But I think coming from the infrastructure type of security, okay, I think that a lot of the times I see that the risk assessment is not done often enough. And it needs to be done often enough because cybersecurity is a dynamic field, meaning a product which is considered secured in this very moment, tomorrow morning, if you take, for example, what was the big in 2022, I think was Log4j, for example. So all of a sudden you have all these products which are not secured anymore. Now, when we see such things like these products being unsecured and CVEs published 0 days, etc., and not only 0 days, even 1 day, or third parties, libraries being exploited and reported, our main say gut feeling is to go ahead and patch it. And we are missing something a lot of people missing something very important at this very moment, when it's now we have a problem and we need to fix it now. And I think that the evaluation of when the problem actually affects us, what is the impact, evaluating the impact of the problem, because sometimes, you know, the best examples is from time to time an exploit in the, for example, in the Intel processor or in a certain chip on a board of a computer is being published, and everyone is rushing in to start and getting the patches and everything. Now, I think that when, and I take it from what we call zero tolerance security products, meaning places that cannot really compromise on security. I think that there needs to be an evaluation, and we don't see this evaluation being done enough or in a professional way. And the evaluation is a simple questions that we can ask ourselves. What is the impact of this problem to my infrastructure or to my products? What is the likelihood that something like this would happen? And we don't need to rush into fixing each and every problem somebody reports to us. Okay, because we need to evaluate the risk, and this is exactly the risk assessment process. And the risk assessment process should be done on a cycle every time we can decide which period, depends on the product, what is its exposure, etc. Second thing in cybersecurity balance, and this is an often mistake, is that a lot of the places treat technical people, the hands-on personnel, a lot of the places treat them as security aware people. And this is 100% of the time not the case, and even contrary. And I will explain. The people with the hands-on, technological people with the hands-on, are often the people that are able to open the product or the infrastructure to a greater risk than the people in the back office, such as the people that gets today normally the training, which are the accounting and the accounting department and the secretary's department, etc. I think that building a well-aware security culture in the technical teams is a must for each and every company, and security programs should come not, and security also tests, like today we have the companies that are sending, for example, phishing emails, and they are checking certain security aspects of workers, regular workers in the company. I think this should go also to the hands-on. I call them the hands-on, but in truly this is all the high-tech personnel within the company. The security should be adaptive and dynamic because it's a dynamic topic. And when I mean dynamic and adaptive, I mean you should not trust only technology to protect your security. We all know that I think if we take the top 10 companies on the on the Nasdaq, and we cannot think that they are not investing in security. I think the common ground to all of these companies is that if we go 5 years back, each and every one of them was reported to be hacked at a certain point. And one more thing which is missing, and I see it all the time that it's missing, is in God we trust, all other we monitor. Visibility is a key factor in security. And it's often neglected because we tend to deal with the technical part, with the penetration test, with getting the 0 days. With today there is I don't know if you know CASM, it's a security asset management product. Okay, we tend to deal with the technology of these things, but when you look at how many people really monitor their products, and we can do a huge amount of detection inside the product, a huge amount, by achieving visibility, true visibility and full visibility on what the product does and all what the product is doing, and on what happens in the infrastructure level. And I think if we will do all this and we balanced it, we are going to balance it with technology, and we're going to invest the resources in both, not only in one thing, but in both or in many aspects of security. And yes, it will come in a price that maybe I would not implement a certain technology that might help me. But we cannot neglect if the budget or the resource I'm focusing in on the technology means that I will have less visibility, or I will have lack of visibility. We need to monitor. I mean, we need to evaluate that and see where we should put the resource to. It's not obvious automatically technology as we see it in many places. Another thing that is very common, and it's a phrase I've been saying for a long time. I think we are past the time that we are trying to protect that the main goal should be protecting our product. Yes, it is the main goal, but I think it's more important. And again, this is things that you don't see part of the procedure of a security for a company or a product, that a company developing a product or developing its own infrastructure. I think the more important thing is have your team and your management prepare for the day after the attack, and not just write some kind of procedures, etc. Really try them. You know, there's a story back in the days, many people used to do backups, and then when they needed the backups were not available. There was an error, they couldn't find the encryption key, etc., etc. It's the same here. if you don't test your backup, if you don't test your system, if you don't test your policy, the day after the attack, you will find yourself starting to study what I should do. This translates directly to resources and money that the company will invest in fixing the problem. And when it comes to BCM, meaning business continuation management, it's a lot of resources, it's a lot of money, and this needs to be part of your program. Have procedures stating this and that happens, and not only have procedures stating this and that happens, but really do it, simulate it, and see how the company reacts. Train them to react in time. Each and every part of the company should be in place and act upon the procedure. Another error commonly seen is when deploying new security technology. A lot of the people ask, what does this security technology give me? Either in the infrastructure or for your development cycle. But the true question to ask is not what is this security technology gives me or what it protects against, but what attack vector, which is uncovered or partly covered on my assets, what attack vector on my assets, which is partly covered by this technology, meaning we need to evaluate the differentiation between the coverage with the new technology and with the old technology, what we have currently. And you'll be surprised that a lot of the products, and you see many duplications, especially on infrastructure security, and coming from security design and architecture, I can tell you that too many products that secure you, at the end of the day, they create a complexity which is unmanageable. If we talk about networks, I think the latest statistic for security tools on an average company network, I think the latest was around between 18 and 21. And when you go and you see what was deployed, you see a lot of duplications. Now, when you evaluate the assets and evaluate the risks, a lot of the times you will see that some of these products, some of these technologies are redundant, and you will save resources, but not only because of this. I think mainly I'm a really big supporter of the KIS, keep it simple. I really believe in simple security, not complex. I think that complexity is the enemy of security. Okay, so sorry. Here it is. So I think the takeaway from this talk is is that we tend to go often to products that will secure us. And judging from researching incidents, really researching them by being part of the IR teams and consulting and doing gap analysis, post-attack gap analysis on companies, I think that we trust more technology and we give less resources to methodology and policies. And I think there are a lot of places where methodologies and policies would have saved the company better than the technology they deployed. And I will be happy to answer any of your questions now.
Okay, guys, thank you very much. Thank you, Eddie. Guys, if you have any questions to Eddie or to any other lectures, please write them down in the Q&A. We will answer all your questions. feel free to write in the Q&A. I think there is one question to Rotem. Rotem, someone anonymous is asking, how do you get over the feeling of not knowing enough? What do you think?
So it could be not knowing enough in multiple areas, I guess. It could be in general, in the position of the imposter syndrome, or it could be something that you don't know about, one of the applications that you have internally. Eventually, you can tackle it from various angles as well. So you can say, okay, I'm going to learn this stuff that I'm not that good at. It could be just one example, Kubernetes. I want to become a Kubernetes expert, so I will need to set up my own cluster and to play with that. Or if it is in one of the applications that you have, because sometimes you will need to defend on an application and a technology that you don't know how to work with. So you will need to sit maybe with the developers or with the DevOps teams and actually understand from them what they are doing, what is this technology, and just proceed from there. So it highly depends on the actual question here.
Yes, I think also from practical or day-to-day, there are always risks. Okay, there are always risks out there. There is always something you don't know, or someone invented or found a 0 day or something like that. And I think the approach here is, as Rotem mentioned, and also Bar talked about it, and Eddie talked about it, to build secure in depth. So actually combining three things, combining people, combining the technology, okay, the right technology to use, the right tool set to use, and the process, okay? So
if I may,
not just to shift left. Yes, Eddie.
Leo, if I may, because I relate to the question very much, like feeling you don't know enough. And I think that at some point, I mean, for me, what happened was that at some point I knew that, first of all, you cannot know everything, and trying to grasp everything, which is an often beginners try to grasp everything all at once and learn everything and study everything all at once, will yield eventually lack of knowledge in many, like you will know several things, but you will not know them in depth, meaning you will be a little bit shallow in these things. I think that eventually you need to also here, you need to balance on how deep you go into each and every technology, and how much do you really need to know. And I think it's an acquired talent. I think that at the beginning you're very much all over the place, and once you get used to it, you start to understand, here I will go into this and that level, this is already too much, etc. And once you know principles, and I'm today I'm not a programmer, but I come from programming. But once you know a lot of principles, you will see that a lot of the principles that you know also in security, they are duplicated between the technologies. So it's eventually, once you know something and you know the principle and how it works, it doesn't mean you need to know it on each and every technology. You will be able to enter relatively easy to a new technology.
By the way, I must say that sometimes even developers doesn't know the technologies that they are working on. So this is why it is also important to have more controls in the process and more layers of security eventually.
Yes, that's fully correct. And Eddie, I personally loved your slide related to the culture, not just awareness, but the culture of the organization. So if the organization has a culture of securing, they will also assist you as an application security or CISO to implement security. Okay, they will assist you. They will be your right hand, and together, in culture manner, you will establish a strong cybersecurity. And of course, you don't know everything. Also, a developer, as Rotem said, doesn't know everything. but
100%.
you will cover most of the aspects, and I truly connect on that. Bar, do you want to add anything from tool perspective related to the coverage or depending depth?
I think you all cover it pretty nicely, but basically, yeah, the basics are important. Doing the basics is like there is no point in investing in some super crazy all doing solution or tools when a third-party library or a single XSS can take your solution down. So do your basics, then go forward.
Okay, great. Guys, if you have any questions, please write them down to each and every, in the Q&A. If you have any questions to our lecturers, please feel free to ask now. And, we can contact each and every one. As I mentioned, the recording of this session will be uploaded to our LinkedIn page. I have sent the link in the chat, so you will be able to see. We will upload it to our LinkedIn page. And if there's no further questions from the audience, I do want to thank you, the lecturers, Bar, Rotem, Eddie. Thank you
Thank you so much.
for your time and presenting from your experience. I think it's a very interesting topic that will, continue to be very interesting in the future, including the AI. Okay, so the AI and the new technology and the AI technology will actually enrich or enlarge the attack surface and the defect in cybersecurity and also in application security. So thank you very much for that. Have a great evening, and see you in the next meetup. Thank you very much, all.
Thank you, everyone.
Bye
Thank
for
you.
now. Bye-bye.
Bye-bye.